And it seems the webinar has started. So hello everyone, this is Luboš Pirkl from CFD Support. I would like to welcome you to the webinar where we will introduce the new version of TCAE. It will be version 22.10, which is the new version of our flagship software, and it's our pleasure to show it to you today. Once again, we have spent enormous time and effort to deliver this version, and we believe it's once again the best version we ever made. So it's a pleasure to show it to you today. So in today's webinar, the webinar is being recorded, so the recording will be made later publicly available. So please keep this in mind. There will be a Q&A session dedicated to your questions and our answers, so feel free to ask your questions anytime during the webinar, and at the end of the webinar there will be a space to answer your questions. So we will do our best to answer your questions. So no, not this thing. Okay, I'll enter the full screen now. Okay, so I think we can continue, and let's see how it goes. So first of all, there will be webinar speakers. As normal, as usual, there will be these usual suspects. So this is me. My name is Luboš Pirkl, and I'm co-founder of CFD Support. And at the time being, I'm storyteller here, and I'm helping to enable things and run the business. And together with me, there is Radek Máca, who is our head engineer, senior developer, and also golden boy of our company, and guy with golden hands and golden heart, of course. So Radek, can you hear us? Is everything working well?
Yes. Hello, Luboš, and hello to everyone who is listening us and watching us at the moment. So yeah, everything works well, and I'm so anxious to present our new version. So just please going on.
Okay, Radek, thank you very much. So can you see the nice red circle I am doing right now around your head?
I can see a small red worm. Yeah.
Okay. So maybe it's nicer on my screen because it's
Yes, it's there.
Okay. So very well. So I think we can let's go ahead.
Yeah.
So okay. So as usual, there's a little agenda of today's webinar. So in the first introduction, I'll give a general introduction to what's going on, and the concept of what we are doing and what we have done. And later on in the second part, Radek will show you a little bit more details about TCAE and software. And in the latest part, there will be a Q&A session dedicated to your questions and our answers. So I would like to ask you again to ask your questions. It's your time, use it to the fullest, and that's why we make it live. So this is live session, and we would like to answer your questions and know your feedback, and also do our best to make everything transparent. All the questions will be answered. The most representative questions and the most relevant questions will be answered right away in the webinar. The rest of all the questions will be answered later via email, because we can see them in the spreadsheet. So ask your questions. It can be ask about anything. We will sort it and answer it. Okay. Quick general introduction. So I guess you know CFD Support is a company located in Czech Republic, in Prague. I guess you know that we deal with simulations. We've started as a company for CFD simulations, but later we extended our portfolio of services and software with FEA and FSI and optimization, and now with this release we are also including the acoustics simulations. So it's our pleasure to enter this field and this challenging field and help our users also with acoustics. So before we will tell you what's new, I will start with what really is TCAE. So I guess you know it, but still, TCAE is a simulation environment. Sometimes we call it also simulation environment. It's not just a software. It's an ecosystem of individual standalone plugins that can be used. And we develop it out of open source, and we make it additional value with graphical interface and experience and tuning things and making them communicate together to make a professional tool out of it. And there are a couple of principles we follow. Number one principle is we want to keep it as flexible as possible. So TCAE is definitely very flexible. It's ready it fits any existing workflow. So the engineers can use it according to their needs, skills, project goals, requirements, users' experience, and also resources available. So, for example, users can use just CFD engine or FEA engine, or use it everything all together as a big one complex workflow. It's always up to the user, and it's created with the incentive to help users with complex workflows, and it can be combined with existing software. It can be combined with in-house codes, commercial codes, other open sources. So it's very flexible. So it's principle number one. Principle number two, it's unlimited. So there are no limitations on the number of TCAE users, job scores, and hardware installations, and that's why our users can use TCAE to scale their resources to the fullest. That's important, another important principle. So they can scale their resources, and then they can use on-site resources or also clusters and clouds and everything, and still for the same price. So we believe it's fair enough. And another important principle for us is TCAE is focused on particular simulations, and it's for that reason it's very accurate, because it can be focused on where it's good, and it can be tuned for special applications. So it's aimed on turbo machinery and external aerodynamics. That's a big deal. It's definitely not a general purpose code, and I have to say we are here at CFD Support, we are obsessed with the accuracy, and we know after the years that a very successful project is based on skills, experience, patience, and dedication, and not random actions in a rush. So that's another big principle we follow. And perhaps lastly, everything has to be automated to save time and costs and everything. So TCAE can be definitely perfectly automated, and it's the user who decides how it's going to be used. It can be used either as a black box or completely high-end simulation software, and it's always the decision of the user. So these are a couple of principles we follow. And now I'm getting a little bit to the new version. So this new version is we had it took us a year to deliver the new version, because for good reasons we made a lot of new capabilities and features, and many things, and we for the user the good things remain, but the new things and things we didn't like, we completely replaced them. We have undergone a complete code redesign. So the code that drives all the processes and everything has been redesigned completely. So the graphical interface looks similarly to the older versions, and we also did our best to follow the backward compatibility. But in fact, a lot of effort has been spent, and I believe it's a new level, and it will be new experience for our users, and we are definitely ready to prove it. So the complete project management is different, and the experience will be different, but I guess it will be explained a little bit more later in this webinar. I'll go further. So as you know, here at CFD Support, we have mastered the process of integration of open source. So TCAE is not just okay. We as you, I guess you know, we started as a graphical interface for OpenFOAM, but nowadays it's something much more. Currently, TCAE includes more than 60 open source pieces. So those are new versions or the latest versions of these libraries. You can see here those the most prominent open source pieces are, of course, OpenFOAM and ParaView and Calculix and NetGen and Python, etc., etc. But of course, there are a lot of software pieces, and the effort that has been taken is enormous, because we have to compile everything natively for Windows and for Linux, and we have to maintain everything to work together. And in total, it has taken more than 40 many years to deliver this. I mean, aggregated over the time, but still, it's enormous time has been spent. And I have an advice for you: if you ever get an idea to create a CFD or CAE software, please don't do it. It's not a good idea. It's really a lot of work. Anyway, we made it. The new version is here. Seriously, now the new version is here, and we would like to share the news with you. So the version 22.10, it has been actually technically, the development has been split into more than 200 projects. So there has been resolved more than 200 issues in our GitLab. Some of them were big, some of them were pretty little, but still everything has to work smoothly. It has been tested through 3 levels of testing. There's the code development testing, and the tutorials testing, and benchmarks testing to the final results. So it has taken the testing as itself has taken so much effort, and so it's here. As already mentioned, the complete code has been redesigned to get the new project management. Maybe I can mention a little bit here that before TCAE was like the results generator, which was good, and this property remained, but now it's gonna be more like project oriented software. So you can close the project, get back anytime, and really maintain one project with change everything all the time, and know where you are, and like take care of your project more precisely and more accurately. Perhaps the most visible thing of this release is the new acoustics module. So the new software module called TCAA is being introduced. Today we will just mention it, and there will be a new big webinar only for this TCAA module, which will be in November 29th to 2022. So in 20 days. November 2029, we will make a webinar specifically dedicated to TCAA module. So it's this, and also we have some new advancements in the optimization module and graphical interface, etc., etc. So that's what we will talk about today, and of course later on. And yeah, we're also, of course, we have some other development plans for the future. So we are already a little bit working on the new version, and from the next month we will start heavily working on the new version, which will be again, we believe, bigger, because we will employ a special module for database of results, and of course machine learning and artificial intelligence modules are on the way, because we believe it's a really big thing, and we are absolutely sure it will completely change all the engineering everywhere, field by field, and also engineering simulations. So you can look for this. We are already working on it, and it's a really big thing, and tremendous change in the thinking of simulations. And yeah, we also running a big project on to resolve the cloud computing, because we believe that there is a way which can be used. It's client server, so you stay with everything on your PC, but you can send the task for heavy lifting on the cloud or on the cluster or another computer. So it will be a big new approach to cloud and such a parallel computing and HPC. So you can look forward to it. And I guess this will be almost it from this introductory part. And I would like to ask Radek whether he's ready to take over.
Yes, hello Luboš again. I am ready.
Yes.
So just let me know if you can see my screen.
Yes, we can see
I
it.
will go for it.
The stage is
Okay,
yours.
great. Okay, thank you. Thank you, Luboš. So hello again, and let's get directly into today's goal. So it's let's say a little bit more detailed information about the new features developed for the new version TCAE 22.10. Okay, so this is the list of the main features I will be talking about. So the first one is the new TCAE project management. So I will introduce in more detail how the project case looks like and some kind of new project management operation which are a little bit different from the previous version. This is connected to the user experience and GUI, which includes a little bit different approach to the simulation management, but 95% of the case setup and case management is really the same like the previous version. Then I will shortly introduce the new module TCAE for the acoustic simulations, because as Luboš already mentioned, in 20 days at the end of the November we will dedicate the special webinar just for introducing this new module. So to this module, we have tested it on a special benchmark case. So we did a simulation and acoustic analysis for this specific propeller and compare it to the measurement, just to prove that the results getting from this module is relevant and good. Then there are several maybe what I would like to say that 80% of development over the last year was dedicated to the new project management. So there are a lot of new things inside the code which is not seen directly, but it helps us for the future to make the project management much easier, much user friendly, and to introduce new features. So there are many hours of work which were dedicated to change to redesign the code. Then there are some visible features connected to the simulation itself. So there is a new optimization method for the TOpt. There is some kind of small feature which is connected to the healing the input STLs files. There are some improved boundary conditions which make the simulation more robust. There is a new numerical scheme for a kind of heavy non-orthogonal meshes, and some general things. New benchmark for the for the centrifugal compressor stage, because also this is, let's say, the first step to improve the compressible solver. So we would like also to focus on improving the compressible simulations. We have enabled to use the newest paraview, or almost the newest paraview for the GUI. we have enabled the support for client server. So now you can directly through the GUI connect to the server, so to the some high-end computer at your office or at your server room, and you can work from your laptop from home, for example, but everything from the rendering, the data, and so on, running the simulation, everything will be done on the server side. But it looks like you are doing at your laptop. And there is the last but not least, simplified installation in Windows. So all the components are now installed by one click, let's say. So let's go for the first topic, which is the project management. So for many reasons, we decided to switch from kind of, as Lubos pointed, some just results generated to really project directory approach, which we will be extending in the future to really have everything within the project. You can anytime reopen it, and it allows us to implement new and better project management, including the generation of the results, simulations, modifications, and so on. So now everything lives within the project directory. So here's some, let's say, example of the older version where we have just the configuration file and the input geometry. And now if you preset the simulation, so it prepares everything to be ready to run at any point, which also brings other advantages I will show you in the next slides. And now you can, or the project allows to import all the input data from the geometry, from the STLs or external meshes, CSV files for specific boundary conditions or for definition of, I don't know, for example, for FEA analysis or new acoustic analysis, all the data. So they are kept within the project and lives within the project all the time for all the time. So you don't lose it. All right. Then this new project management brings, let's say, a new workflow or approach to create the new projects. So let's say there is a new project from scratch. So we are really starting from the zero data. Then you can anytime loading the existing project, you can copy it. So you can create a new project from an existing one, and you can also use the legacy we call it legacy files from the previous versions. So you can create the project from the existing configuration file, or for some specific optimization tools or whatever, you can create the configuration file which you used as a template for optimization runs or for exporting from your code from the external tools and so on. So this feature was kept for these purposes. Maybe then I will open the case. And what is the biggest, let's say, advantages from the user point of view? We were able to get rid of the ParaView apply button, which was a little bit annoying, because after you change anything in the setup, you need to always you need it always to hit the apply button and go for the next steps. So now you just change the setup, you save the project, and then you can directly go for the simulation. So there is no need to explicitly writing the case before you go on. So the project, after the save, it always check what was changed and automatically runs or modifies or reruns the existing data, but only those which were touched by the changes. So now just you hit run all, and if you, for example, change the parameters of one component in the mesh, then only this component will be recomputed and the rest will be done automatically. So okay, so I will open the case. So let me use this. So this project management brings a feature that the project itself can be directly directly run. Yeah, so if you see in your favorite file browser, if you go for the new projects, so this one, so any folder looks like a folder. For example, here I have older version of the case of the TCAE 2109 cases. But now for the new project, you can directly open the directory. So the directory is executable for the TCAE. And if I open, for example, this axial fun stage project, so directly it will be opened in the GUI. Yeah, so the project directory is the project itself for the TCAE. Of course, you can anytime go inside. So if you go open in the new window, you can really see and go to see the structure, which is very similar to the previous one. So you can find the data you want directly inside, but in general, there is no need to go inside the project on your disk. Let's say just for the advanced users, let's say you can. Okay, so the project is loading, and then the standard management is very similar and is simplified because there is no need to hit this apply button and writing the case. So everything is always ready to manage the simulation or whatever. All right, so the project is loading, and just to quick, maybe I should open the pipe case, but I think now, yeah, now it's opening. So we can see that the paraview and that the GUI layout looks very similar. There are new buttons here. So here you can create a new project. You can create a new empty project. You can load an existing one, or create a new one from the settings from the existing one. You can load the legacy file or the configuration kept in the single configuration file. Yeah, you can load an existing project, including the results. You can close it, of course. You can use the check button if your configuration is correct and compatible with all the parameters of all the modules. If you make any changes, you can save the project. If the project is saved, then this button is disabled, so you can see it. If I, for example, change the number of, for example, number of processors, you can see either here that now the project is unsaved or it's not saved, and you can see that this button is enabled. So again, you can quickly save it, and everything is again ready for the simulation. Yeah, there is no need to running the case, because for this project I have already generated the mesh. But as an example, for example, if I change some parameter in the, let's say, second component, for example, I don't know, the suction side, I will increase the maximum level of refinement. Then I go for the save. You can directly see, okay, what part of the meshes need to be regenerated, but I can hit the run all button, and it automatically generates only the mesh which is needed to be generated with respect to the changes that I made. So this new project management is always checking for the actual state and for the new setup, and it will always manage what is needed to be run, generate to rebuild the whole simulation again. All right, so this is it. So maybe I will later have other notes to this, but I think I can go slowly, move slowly for the next topics. Yeah, the new module, which is the biggest new feature we have developed for this release. So there is a new module TCAE. So it is designed to calculate acoustic noise from the transient CFD results. So you can, and so the approach is very the same like for FEA analysis, for example. So if you have the CFD transient results, you can then apply the TCAE which will take the acoustic data from the CFD simulation and do the acoustic analysis. The model is based on the acoustic analogy approach, which is tailored mainly for the external flows, and we get the information about the filter temporal signal, sound pressure level, power spectral density, and some others which we will introduce in the next webinar. So the output is the power spectral density or the sound pressure level graphs. These red one is the measurement from this benchmark we will present, and the blue one are the data from the CFD simulation. So meanwhile I can open the case. Yeah, so you see that the simulation is now running, so it's fine. Okay, I will stop it because I'm going to open the new. So it is proper DGI, so I will open directly the project just to show quickly how the interface looks like, but say the principles are very the same like for the other modules. Typically, it's very similar to the application of FEA module. So TCAE module applies on the TCFD data, and there are many options and models which you can use for the acoustic analysis. So you can use the CFD simulation, or you can also import the external data from any other simulation. Just saying which range of the time you would like to analyze from the CFD analysis. You can define as many observers. So this is the point in the space where you would like to measure the acoustics, physical data for the simulation, some signal processing, some special filters, how to process the temporal signals, and some kind of management of the report. So which units and what would you like to see in the report. The TCAE module again has the report in which you can browse through the data. So the acoustics which are obtained in every observer point, sound pressure levels similarly for each observer, and that's basically what you get from the acoustic analysis. Yeah, so the details will be presented in the next webinar. Okay, so go for the next step. Yeah, connected to this new module, we introduce this new tutorial for tests on your site and really to touch this module and to try by your own with the existing data. So the measurements or the simulation were done on this specific propeller type, and the results were compared to the real measurements. So everything will be presented in the next webinar. There is a new feature regarding the optimization module. So there is a new method, direct. So the direct algorithm was implemented. It's a well-known approach, so you can find the source of this approach. What are the advantages? So in the previous version, there was just the golden section search, which looked just for the local minimum. The advantage of the direct method is that it looks for the global minimum if sufficient points are simulated, of course, and it is more robust because the diverge point, it may happen that, for example, if you simulate the many parameters for your design, so some parameters can be off of the working design, or some can diverge from any reason, but this method can extrapolate or interpolate the diverge points from the neighboring points. Yeah, so you don't lost the optimization if you lost some points from any reasons. They are diverging or they are out of working space, or the For example, what happens pretty often that for the particle combination of parameters, the geometry is not generated because of some restriction for the parametric model, etc. So this model is more robust and gives you the results even if some points are not converged or not simulated. And you just pick up it in the T-opt module in the algorithm section. So there is at the moment direct or golden section search. We also improved some combination of boundary conditions. The typical example was this. So if you set a total pressure at the inlet, then internally there was for the velocity field, there was a type of pressure inlet velocity, which for some geometries, usually including the boundary layer, it was a little bit oscillating and makes the solver a little bit not so robust. So there was some oscillation in the boundary layer, and when we tested it and implemented or enabling this pressure inlet uniform velocity, so some kind of we enforce the uniformity of the velocity at the inlet, which is usually what we preset at the inlet, then the simulation is more stable and also the convergence is much faster. So here is the original setup and here is the newer setup. So you can see that the residuals are more smooth and the convergence is a little bit faster. And even for the more complex application, this is crucial for getting nice results at the end. We also a little bit improved the healing algorithm or healing feature for the input STLs, because usually the bottleneck of the simulation is the quality of the input STLs. So some exports usually doesn't care about the let's say waterproofness or point-to-point correspondence. So typically, if you have such input data where there is no point-to-point between the curved parts of the domain, then you can typically see the holes smaller or larger, and this surface hookup feature can heal these holes, but it needs a parameter which corresponds to the size of the hole. So if this parameter is too small, then no holes, no gaps are healed or patched. And if this value is again on the other side too large, then it can connect the opposite parts, and you can see then the zigzag STL, which is which can't be used for the meshing. So now we allow user to setting and tune this parameter to really get the healed surface. So even if there is no possibility how to improve the input STL, so this feature can save the input data and make them possible to use it for the meshing. And this parameter is just the proportional size of the gaps or holes to be healed. Yeah, so this is pretty straightforward and sometimes can save the situation or even the project. Okay, we also introduce the new numerical option, mainly for non-orthogonal meshes, because we are pretty often facing that the TCFD has some troubles and we're too oscillating and say too unstable for the external meshes. Typically for hexahedral block structured meshes, which can have high non-orthogonal cells, faces, and our first or second order scheme was too accurate, let's say, for such meshes. So there exists a combination of the how to interpolate gradients and surface normals and Laplace parts of the model equations, And this model, although it is less accurate, it is more robust and more appropriate for such type of meshes. So here's the comparison. For example, our previous standard first and second order scheme on such a mesh was extremely oscillating. So you can see that the oscillation is more than 10%. And if we enable this these numerics or these discretizations, then the solution is much stable, both for first and second order schemes. So this is new options for the specific meshes. As I already mentioned, we would like to improve the compressible simulations, transonic compressible simulations. So we decided to create a benchmark and which was delivered by, or was pointed by, one of our good customer, and we did this benchmark on this specific centrifugal compressor which is measured. So we did the measurement, and we would try to, even the results are good, we would try to improve the compressible solver to get even better and more robust solver for solving such applications. And it all right, new ParaView. So all the new feature which new ParaView provides and all the bug fixes are listed, for example, here. So this was implemented. We enabled the support for client server, which is a really nice feature, and we would like to extend it for the next releases. The thing is that ParaView was born for such a for rendering huge data, which are rendered on the clouds or servers and visualized on the client side. And we extended this feature also for this TCAE module, or TCAE the source, so basically for our TCAE product. So now you are able to connect directly from the GUI to any server where the TCAE is also installed, and you can simply run huge complex cases from your laptop at home or at your office and directly work like you are doing it physically on your laptop. Yeah, so all the data operations, rendering, and simulations are performed on the remote, on the server side, and on your client side, on your laptop. You're just getting the images, which is great. So let's try to use this. So I will open the TCAE, the new GUI. And I'm now sitting on the Windows machine, and in the next office I have my powerful computer running on the Linux system, on Ubuntu, and we can connect it pretty easily. So I have here how to. So on the server side, you just run the PV server. You can define a specific port and some kind of password. And on the client side, which I'm sitting at now at the Windows machine with, for example, just 10 cores, but my machine in the next office has 32 cores, so I can connect pretty easily. So I will use this connection. Yeah, I would like to disconnect from everything because I would like to start from scratch. Yeah, I will delete it, and I will show you how to make a new connection. So I will here add the server. You can name it. So my supercomputer, for example. You can define the host. So if it's on the same DHCP server, so you can name it by the name, or you can address the IP address, which is in my side, I think 31. The port, I run it using 12345. So let's click configure. Here you just type save, and now I will try to connect there. Now it want me to put the password which I set on the server. So it was something like this. Okay, now I hope I put it correctly. Right. So now I am connected to my server, and now I can enable the TCAE. source for the TCAE manager. So I will put it here in the sources, TCAE sources. I will enable this TCAE manager, and now I can work like I am on my computer on the server from my client side. So if I click the load, now I'm on the disk on the remote server. Yeah, so I'm on my home, on my disk on my computer in the next office. So I can locate, for example, here Axial Fund Stage project. So now everything is done on the server side, but here I will only see the information, the pictures, but everything is done on the server side. But everything looks like I'm really working here on my computer. So let me directly run the simulation. So just for example, to check the number of processors. Yeah, so 32 processors, and on my side I have just 10 physical cores, so 20 logical processors. So when I run the simulation, just to prove you that it is really computing on the server side, so I will run all. And now we can see now the SnappyX mesh is running with 32 processor, but on my side, yeah, nothing is happening. Yeah, there is CPU just 10% of usage. So in this case, you can now work even from your home and connect to your CPU at your office, like you are really sitting there without any additional remote desktops and so on. And everything else works like you are really sitting at that computer. So you can visualize the mesh, which is here. Yeah, so you can directly see the mesh. So you can imagine that you are simulating or generating millions or dozens of millions for the mesh size, but on your laptop, but still you can visualize it without any problem because everything is done on the server side. So this is a very nice feature which is enabled for this version. All right, and the last but not least, we have simplified the installation in Windows. What we simplified is this step, because all the components you needed to click next, but now the installation is done by let's say 6 clicks, and all the components for the TCAE are installed automatically. Okay, so maybe it was faster than I expected, but now we can go back to Lubos just to conclude and to discuss and answer your questions and comments. So Lubos, are you still there?
Yes, I'm here, Radek. Thank you very much for your part. It was nice to see it like an attendee. So thank you for it. Yeah, it was nice. Well, what do we do? I would like to. Yeah, I need to get back to the presentation. I would like to ask the audience to ask your questions, because now it's time to ask. We will do our best to answer your questions. And yeah, so ask your questions. And yeah, Radek, it was nice. I liked especially this last part with the remote usage of it. It's definitely very promising, and in the future we will extend. We definitely will extend these features. The vision is that the user would stay on his PC to do the setup and everything, and then he would be able to send it anywhere for heavy lifting, for the simulations, but the settings will stay on PC for good reasons, because you definitely need a large monitor and some CPU power for the settings and everything.
Yeah,
so
sure.
Definitely makes sense to make some hybrid, to make available some hybrid system that allows using PC and other stuff that the users are used to, and for heavy lifting using the clouds and servers and everything. And it solves all the IP security and other questions.
Yep.
So Good. We have some questions here. So Tim, hello Tim, is asking, is it possible to continue transient simulation from the previous? Actually, that's a question. I'm not sure. So Radek.
Yeah. Well, this feature is remain the same like in the previous version. So if you simulate just one point on the spin line and you increase the simulation time, then it will continue. But if you're simulating more points on the speed line, then you can adjust just the last point, yeah, to continue from the previous simulation. Yeah, but
Okay.
anyway, this let's say simulation management and point management, we would like to extend for the next releases, because we did the main work to really rebuild the code inside to enable it enable this in the future. So this will be the goal for the next updates.
Yeah, but anyway, for single point simulations, which is standard, right? Normally for in transient mode, you very rarely simulate more points. So it's possible to start where you stopped. That's important. Yep. So yeah, we have a couple of questions here. Some of them are specific. Bistrik is asking if the remote connection can be done through SSH, or is it VPN, or what kind of connection actually do we use with current client server? Is it?
This is a good question.
Or does it? I don't know. I don't know. Yep.
It will directly go through the server client for the Paraview, but I think is what is behind is the SSH.
SSH, right? I think so. Yeah, but we need to check this. Yes, it's SSH. So Sophia and Akeladis, it seems he's answering for us. So yeah. So yeah, thank you, Sophia. It's definitely SSH. But the question is, what if the VPN? Yeah. Okay. So
but VPN it's different approach. Yeah? This is done directly through the Paraview server, which is connected on the client server side. So you don't need any VPN. You don't need any.
Yes.
Remote control whatsoever. So you
Yeah,
just
but
need
the protocol is SSH.
behind SSH. Right? Yes.
I think so. Yeah. Okay, but let's check this. It's a pretty new feature. We decided to include it still in the new release. We will definitely extend it for the future. We have a vision that we would be able to send the data and the whole case and everything via this client server connection, but we're not there yet. We think it's possible, not that difficult. So it will be definitely an object of our next development, because it's a really big thing, and we believe that it's the answer for many of us for the cloud computing, because it solves all the problems associated with using external resources, etc., etc. Yeah. Tim is asking about the release date. I tried to communicate this, but maybe I was not so clear in this. We will come to all the users, current users, and send them the software one by one. It will take some time. We believe that in a couple of weeks we will send it to everyone with the new license and version and everything. So please, thank you for your patience, and we will come to everyone, of course. Okay. Yeah. Sofian is asking. Yeah, it's actually good questions. Is the license needed on each side when using client server? I think so, but no, it's.
Yeah, I'm not sure, but I think so.
Yeah,
I think so
I think
too.
it's not important because there's.
Yeah.
You can use. Yep, Radek.
Yeah, that everything what you do on the client is done on the server side, including the TCAE source and which checks for license. So at 99%, yes, it requires licenses on both sides. But I will discuss it with one of our colleague who developed this. Or
yeah, it's strange. I never thought about this. But anyway, it's not that important question because it's of course it's important question. But it's not a big issue because the license is transferable. All the licenses are transferable, so you can load them here and there and to every hardware you have and to scale it. So it's not associated with extra anything. But yeah, it's a good question to realize how it works technically. Yeah, sure. Yes, so we have some other questions. So Radek, feel free to pick some of them. I'm very slow reader, so I need to read.
I think Daniel. Hello, Daniel.
Yes.
He has a question. What about data exchange during optimization runs via third-party like cases? Well, if you from the optimization point of view, it can remain really the same, because for the optimization run you can still use the template data like the configuration file and the external data, and just for each optimization run it will import the data to the project, but still the template will be outside of the project. So you will externally keep the configuration file, the template, which you can update by the script, the folder where the geometry is generated for each parameter variation, and each optimization steps just take the out data on the external side and take it for the next optimization loop. So the principles are kept the same like in the previous version.
Okay. Yeah. Actually, Radek, can you see some other representative questions that are worth I'm sorry, worth to answer at the moment? I think maybe we're done, right? Yeah, there are a couple of questions. We will read them and think about them and get back to you individually. But at the moment, I think maybe it's time to finish this session. Okay, so yeah, so as usual, here are a couple of those who already share our visions with us. So all of you are welcome to join our family. I guess you know that together with us, TCAE is not just a software; it's also being a part of community, and there's a lot of know-how transfer associated with it. So we hope we can work together, and I guess this will be it for today, Radek.
Yeah, I think so. So thank you for watching, and in the next weeks and months we will deliver new webinars and videos how to work with the new version. So we'll keep working on sharing our knowledge with you. So
yeah,
this is just
absolutely.
This is just a start. Yeah.
Okay, yes, absolutely. We will be in touch definitely with the new version to everyone. Don't worry, we know about it very well, and this will be really it for today. So I would like to thank you for your time, for your attention, and let us know if how we can help you. And let's keep in touch. And bye bye for now.
Thank you. Bye bye.
Bye bye.